Chat window. Participants. And screen share. There we go. All right. Yeah, playing Pokemon with my daughter last night because we just moved, right? And so hadn't actually checked out the area yet for gyms and Pokestops. And place I was living before, there was a Pokestop like reachable from my apartment, so I could just like spin up items all day long. No such luck here, but
This is Pokemon Go, right?
yeah.
Esther Store Park's pretty fun.
Oh yeah, totally. I used to go down to the
I-
fort on community days, and that's always awesome too.
That's funny. We did Esther Store Park right when the game first came out,
Mm-hmm.
and you'd be surprised how many people were down there playing Pokemon Go.
Oh yeah. It was really cool that first summer, I thought, because I could like go down Main Street, and 9 o'clock at night there'd just be like people out, like walking around or hanging out, sitting somewhere, catching Pokemon and talking to each other. But it really felt like more people were getting outside and socializing than I remembered seeing.
Yeah. Oh yeah.
And then the whole COVID thing is kind of like a counterpose to that. It's really weird. So
Yeah, I think we've been on restriction too long. People aren't going to bounce back as quick.
yeah. Or they might bounce back with a vengeance. I mean, everybody might suddenly be like, just like super social, which I think would be pretty awesome.
That would be cool.
Yeah. So yeah, we fed my Pikachu buddy, and then it let us take pictures. So I even got photo bombed by the other creature. Cool. Yeah, change your icons to Pokemon. That would be cool. All right. Any questions? Any issues with the ODP? Current questions with PA4?
I got a quick question. I got the ODP to work and everything, but when I did it, I had to do string length -1
Mm-hmm.
to get it to actually cut off.
Right.
When we were talking about it, we said string length, for index, right, which would be set for hello would be 5, would be the total number of characters, right?
Mm-hmm.
So if you take the index and turn it to a null character, that should be the 5th digit or the O in that case, right?
Well, not actually. So this is the funny thing with index origin 0. If you look at the indices of each of these, the last character is actually one less than the string length.
Okay, so it's not gonna. So basically, what I thought it was 5th position is where it goes. So it starts at 0 and goes 4.
Right.
5s.
Right.
So if you go string length, so it's looking at 5 because the value is 5, not the 5th position.
Right. Yeah, so that's the funny thing with arrays. The 5th element is index 4. The 10th element would be index 9, and the first element is index 0. That's where it all starts from.
Okay. Yeah, I knew that. I just thought with 5 it was looking at the 5th element being number 4.
Okay.
Or element 4. So okay, so that makes more sense.
Yeah.
Thank you.
Welcome. All right, so let's play around with the dialog command, and someone just asked about using calendar commands. So I want to dig a little further into calendars with dialog, and this is going to take us into another utility called awk, which is a good one to be talking about. So send me an attendance note. Let me know you're here. Someone got ODP 461 to work in 51 characters. Cool. Yeah, it would be interesting to have a competition to see what the shortest ODP is that works. There's always contests for like the longest program, like how complex of a hello world can you write. But it's also interesting to try to write the shortest possible
you know, in I think in 120 when we were doing Python,
Mm-hmm.
they gave us an assignment and said we couldn't do it in more than 4 lines,
Oh, okay.
and it was the 99 miles a year on the wall, you know. So
Oh,
you just
cool.
do a loop.
Huh.
It's, you know, I think in Python it was like 3 lines. I think was the lowest you could go
Oh,
to
cool.
get it to actually work, which was kind of cool.
Awesome. That's a fun assignment, sounds like.
Oh yeah.
All right. Well, let's dig into some more dialogue. And you know, we know our basic command looks something like this, right? We can just, the dialogue's the name of the command. We can say dash dash and say what kind of widget we want to display. For an info box, we have an argument, which is the information we want to display, and so this just displays a box that says hello. The 0, 0 are the dimensions of the box. 0 means use the default dimension, but if I change one of these to like 30 or let's say 20, right, it makes a really wide box. If I change this first one, you know, to 20, it makes a really tall and wide box. And so we can make this box whatever dimensions we want, but if we just want it to be, you know, a box that looks reasonable, we can say 0, 0, and it'll figure out the right dimensions to use. So most of these commands have a 0, 0 at the end.
The 0, 0, like if you put a really long string in there, you know, not just hello, but like some kind of long instruction, does it adjust the box to the right size?
It'll adjust and it'll wrap.
Okay.
So yeah. Yeah, so writing deliberately long programs is fun. Like if Boolean equals true, return true. Or you could say, you know, if Boolean equals equals parentheses 1 equals equals 1, then return, you know, 1 equals equals 0 or 1 equals equals 1, and you can just kind of go on and on. All right, so we have this dialog command. We can do things like put this inside scripts, right? So let's make a script S1. And let's display an info box inside the script. So make your script runnable, and you run the script, it displays the info box. Dialog is really just like any other bash command. So it can go inside a script like this, and when we execute the script by saying S1, it does this, which pops up, you know, an info box in this case. All right, question, does a function require a declaration of the type, especially if it's not returning anything? In bash or in C? In bash it does not. In C you always need to specify a type, but if it's not returning anything you can say void. But in the front of the function name there has to be something like int or char star, or if you don't want to return something just say void, V-O-I-D. And I think it'll yell at you in some meaningful way if it doesn't find that. All right. Well, we have a way to display information. We can also get input from a user, right? So we can do an input box. So if I say dialog input box, who are you? It displays a box that says who are you, and you can type in a response. And I can hit enter, or I can click on OK, or I can tab to OK and say space. I'll just hit enter. And you notice that I got a little black box here with green text saying I am me. That's the output of the dialog command, right? Dialog will sometimes produce output. For example, when you say show a calendar and let the user pick a date, the dialog command concludes by printing out the date that the user selected. In this case, the dialog command concludes by printing out the string that the user typed in. And if we're doing this inside a bash program, it's useful to be able to capture that output and store it in a bash variable. And we do this with backquotes, right? You can run any bash command, and if you put it inside backquotes, you can capture the output. So pwd shows me my current directory. If I say x equals backquote pwd, it doesn't display anything, but it saves that result in this variable x in this case. So we can do the same thing. We can take a dialog command, and we can, save this in a variable by putting this inside backquotes. But we got to do a little bit of trickery. If I just try this, it does not work very well. I don't see my dialog box, right? Because the stuff that's making this dialog box appear is getting loaded into this variable x. And if I look at $x, it's, who knows. So we have to do something different if we want to capture output from dialog. And this is just something that you're going to type, a million times in the course of PA4. So it will look a little weird. -- output -fd space 1 space 2 greater than space /dev /null. If you do that, your dialog pops up. I can say you misspelled who, and since I said x equals all of this, if I look at $x, now it's whatever I typed into my dialog box. So we're going to do this kind of thing a lot, right? We're going to run the dialog command, but we're going to put it all inside backquotes, and we're going to add this extra switch. I'll put fd 1 2 greater than dev null. And you don't have to worry about what all of this means. I can explain it to you to some degree later if you're interested, but this was one way to say I want dialog to display the dialog box on the screen, but the output that you generated at the end, don't display that on the screen. Stick that into, this variable x. So we can start putting this together into a script. Ask the user for their name, and I'm going to say, who are you? And I'm going to capture the result of this and store it in this variable called name. And I'm just going to tell the user what I just learned about them, which was their name. So I'm going to say dialog text box you are $name. I'll do an info box. Alright, so we'll put up an input box, ask them who they are, let them type something in. Whatever they type gets stored in this variable name. And now I'll make an info box and just display, hey, you are, and I'll tell them what their name is. Alright, so we run this, who are you? I am Nick M, and it says, you are Nick M. So this is just test code. This is playing around with a command and starting to explore how we can use this command inside a script. And that's really what PA4 is, right? Yeah, go ahead.
Out of curiosity, are you going to be really worried about formatting and stuff? So do you want it to be Nick M all in one line, or as long as you get it up there, it doesn't really matter?
This is all up to you. You get to decide what looks reasonable and so on. If I wanted to not have that split up, I could force the width of this to be 60 characters, for example, which would be big enough for most names. Or I could maybe, I don't know if this will work or not. Maybe I can put a new line in here. I don't think that'll work, but let's see. Nick M. So you are Nick M. Hey, it worked. So here, I'm putting out a new line before I start the name, so it comes out on a separate line. But yeah, you have, you know, creative freedom here to do what you think looks good, um, and do it however you choose. All right. So someone asked in chat for more detail on this. I don't want to get bogged down on it today, but basically, I think the deal is we are changing dialogue so that the stuff it normally produces that displays, you know, the dialog box is being sent to standard error instead of standard out, and the backquotes are capturing standard out, and so we're preventing it from capturing the escape characters, you know, that generate the box and the shadow and so on. Um, and this is saying that any output that would normally go to standard error goes into the bit bucket, so we don't see it. I don't think that's exactly 100% accurate, but that's approximately what's going on. We're fiddling around with the output devices. There's standard out, there's standard error, and we're fiddling with it in such a way that messages we're not interested in will disappear in the bit bucket. Messages that produce the widget will still go to standard out to our display, right? I think through standard error, and then the output that this produces, like, you know, what did the person type in, that goes to plain old standard out, so we can capture it with the back quotes. But it's a fun thing to play with.
I think you missed the quotes.
Did I? Nope, that should have captured it. There we go. So this is what the output of that dialog command was, right? I captured in a variable x. If I just echo $x, it just prints a blank line. But if I echo $x and I put it through this utility that displays all of the characters, here's all the stuff that actually got produced by dialog and saved in that $x. And these brackets are character 1b, 16 and 11, 27. That's an escape character. Sorry, these periods. An escape bracket is how you begin these control sequences for doing things like moving the cursor, changing the color of the output, so on and so forth. Some people have discovered these already and have used them to, you know, highlight text in the high-low game and things like that. And it's the same thing with the steam locomotive, right? This is just generating a bunch of ASCII characters. If I put that into XXD, right, we can see a bunch of characters being produced, mostly containing escapes followed by brackets. All right, so let's see. We are asking the user for their name, we're reading the input from them and capturing it in a variable, and then we can use that in an info box to see their name. So let's look at breaking scripts into separate files. So if you're working on this in a group setting, right, you may have one person working on, you know, the introduction to the program that says, what do you want to do? And you may have one person working on saving appointments in a file and retrieving them. And you may have one person working on, you know, some of the additional features and so on. And so you might be developing your script in a bunch of different files, right? And it's kind of hard to have 3 or 4 people all editing the same single file. So it can be useful to split things up, and we can do that in Bash by executing Bash scripts inside a Bash script, or capturing the output of Bash scripts using backquotes. So for example, we could write a separate script called getName, So this script is just going to ask the user for their name. And it's going to use a dialog box. It's going to do an input box, all of that business. And when it's done, it's going to capture the person's name in this variable called name. Now, how do I pass the result from this script called getName back to my main script, which is called S1? I can do something like this: username equals backquote getName. This is going to execute this script, and whatever that script outputs is going to get captured and stored in this variable called username. So all I need to do here is output what I want to pass back to the calling program. So this is going to do the dialog, find out the user's name, and then it's just going to display it to standard out. But when I execute this, I'm going to do it in backquotes, and whatever that script outputs, now that's going to be stored inside username. And then I'm going to make another script called, display name, and I'm just going to pass it the username. And I'm going to let that be the thing that displays the name. And so let's make that. So this extra number exclamation mark doesn't do anything, it's just a comment. I just kind of have it there as a separator. So what am I going to do inside here? I'm going to display whatever $1 is, because when I run a script, let me just go back to a normal space. When I run a script, if I say display name blah, right? When that script executes, I can pick up blah in the variable $1. So in display name, I'm going to use an info box and just display the value of $1 after I say you are $1. Nope, no ODP today. All right. So what do we got here? We've got three pieces. We've got our main program, which now looks nice and clean, right? I call getName, save that in a variable. I call display name, and I pass it that variable. So this is my main program, right? Display name is just something that takes an argument, displays it in an info box, and getName is something that displays a dialog box, captures it in backquotes, all that kind of stuff. So if I do this and I run S1, it says, who are you? And it says, Nick JM, and it says, you are Nick JM. So you can modularize Bash pretty easily. You just kind of have to think about how you want to pass things. And passing things to a script is pretty straightforward. You just put your arguments, after the name of the script. And the first argument will be $1, the second argument will be $2, and so on. To get results back from a script, you can use this backquote trick, right, which will capture whatever this sends to standard out and store it here. And if you want to pass back multiple things, well, you could print multiple things on a line, maybe separated with a pipe. And then we could split that result back into pieces and get back more than one piece of information from this script.
So for that, would you do like get name $1 and then get name $2, like that kind of thing? Or?
So we need to figure out how to split things up, and that's actually our next topic. So for example, let's get a date. So let's say let's get a date. So D equals get date. All right, so let's ask the user for their birthday. When were you born? That's your birthday, and we'll let go birthday. I don't think this will work, but let's try it anyway. Who are you? I am Nick. When were you born? I was born November 17th. Well, I didn't do anything with the birthday. Equals display name, username, born on $D. Alright, who are you? I'm Nick. When were you born? I was born today. You are Nick, born on 5th of November 2021.
I saw that it was May 11th. I was like, wow, that didn't work.
Yeah, I know, right? Yeah, so day, month, year. Decreasing resolution. Someone got ODP 461 into 46 characters. That's cool. Let me think. What's 461? Chopping it off. That's a good question. How small can you make it? All right. So let's play around with this date. Let's think about dates. We get a date back from the dialog, and by default it's something like what's today? The 5th of November 2021. So it's day, month, year. Now we're actually getting back 3 pieces of information from this getDate command, right? If I just say getDate and I pick a date, right, I'm actually getting back 3 pieces of information. I'm getting a day, a month, and a year. And it would be nice to be able to split those into different pieces. For example, to be able to break that into, a variable called day, which is equal to 9, a variable called year, which is equal to 2021, and so on. And so we're going to talk about another command called awk. And awk is a much bigger subject that we'll address at the end of the term. We'll spend a few days just playing with awk. And awk is a whole programming environment. You can write complete programs in it. It's Turing complete. It's got all kinds of bells and whistles. But we can do one very specific thing with awk without knowing any of the other details of it. We can use awk to break an input line into pieces. Alright, so first way to think about this utility awk, it takes a line of text and it splits it into fields. And by default, fields are just things separated by spaces. So here's a really simple example of using awk. Awk print $1. And the print $1 goes in curly brackets inside single quotes. Okay, so this by default will read standard in and copy the results to standard out. So if I say this is a test, it prints out this. If it says I am hungry, it prints out I. If I say very strange, it prints out very.
And this is only with spaces?
This is only with spaces by default. Right? So this will print out the first field, where a field is, a thing separated from other fields by spaces. And if I print $2, not very surprising, it prints out the second word on each line. And if I don't have a second word, it just prints a blank line. So if we had a date separated by spaces, we could use this to pick out the day, we could use this to pick out the month, and we could use this to pick out the year. But our dates are separated by slashes. Well, we can tell awk to use something other than a space. So we can use a switch dash uppercase F followed by a character. And this character, the slash in this case, becomes the field separator. So if I do this and I say 05/11/2021, it prints out the year. If I do a $2 on that same string, it prints out the month. And if I do a $1 on that string, it prints out the day. Alright, so awk by default is reading from standard in. But I can change what standard in is by using a pipe. I can say something like echo quote 05/11/2021, pipe that into awk, field separator of slash, program of print, field 1, and there's the day, and there's the month, and there's the year. So if I say something like D equals get date, and I pick a date like November 30th, instead of echoing this string, I can echo $D. Well, there's the 30th, there's November, and there's 2021. So let's
How could you use that to, like, print a full statement like, oh, you born on the 30th or something like that.
Mm-hmm.
Printing that part of it.
So let's do that. Let's get the date, and I'll add a comment over here. This is in the format day/month/year. All right, so I'm going to say echo that variable, pipe it into awk with a field separator of a slash, and print $1. That's going to give me the day of that date, and I'm just going to capture it using backquotes. I'm going to say day equals backquote, all of that stuff.
Okay, so we're just declaring a new variable.
Mm-hmm.
Use that to print. Okay.
Yep, and so I'm going to do exactly that. I'm going to pick off field 2 and save that in a variable called month, and field 3 saved in a variable called year. And now I'm going to change my message. I'm going to print out your name. I'm going to say born on day, month, string month, in the year, $year.
So the backquotes, it'll completely get rid of the echo statement. It just captures it. It doesn't display it.
So the echo statement normally doesn't get displayed. The echo statement is taking the output, but it's sending it to standard in of this command. But this command normally produces output to standard out. That's where the backquotes come in. This whole thing, the result will be to print, the number 2021. Instead of displaying that, it gets captured, and now this statement says year equals 2021.
Okay.
It's a really kind of weird mechanism, right? It's kind of replacing part of the statement with something and then executing the statement.
Yeah, it's kind of a cool command.
Yeah. So assuming all of this worked, let's see what happens. So who are you? I am still Nick, and let's do November 2nd, 2021. You are Nick, born on day 2, month 11, in the year 2021. All right, so what's going on here, right? We've got, strange looking statements up here, and all kinds of things going on. So this is sample code, right? And this, is probably usable in PA4 because you're probably going to want to be able to take your dates from a calendar selection and break them into pieces so you can compare dates and so on and so forth. But more generally, right, what I'm trying to show here is this idea of taking what you know and figuring out how to use it to do something else. Now there's probably a way that I can use a switch on the calendar command and say, hey, I want you to display year/month/day, right? Like a US style. But you know, we could do this by saying, you know, you were born on, I don't even remember how we normally do this in the US, so I'm just going to do $year slash $.
Month, day, year.
Okay. Because I usually do it military. So, you know, Nick, pick a date. And so now I've got, well, I did it backwards, but I've got month, year, day, right? If that's something that I wanted, right, I can create a string in that format, right? And I could even, you know, set some other variable equal to this. And now I don't need to know what that extra special switch is inside the dialog command for a calendar, right? So a lot of programming, not just in Bash, but you know, in general, is having a toolkit with a few good tools that you're really comfortable with using, and then visualizing problems as something that can be solved with those tools. And I'd say that's probably the essence of programming, is taking a problem and reimagining it as something that your tool set can handle. And it may mean, you know, taking something and breaking it down into smaller pieces so that we can put those together, you know, using $signs and slashes like this or something. But that is a far more useful skill than being able to, you know, hop on Stack Overflow or you know, Geeks for Geeks or something and find a piece of code that somebody wrote to do what you're trying to do, right? That's a useful skill in some ways, and it's useful for like sample code, but your most valuable skill, I think, coming out of this sequence is going to be being able to take a problem and reimagine it as a problem that you can solve with what tools you have available. And the tools that you come out of even just CSE224 with are probably sufficient for pretty much anything that you're going to want to do in Bash, right? At least, you know, for a bit of the foreseeable future. But it's knowing how to use those, right? And it's Lego blocks, it's Minecraft, it's all this stuff. It's, you know, here's my building blocks. I've got a wooden pickaxe, right? How do I build a castle? Well, I'll cut down some trees and I'll burn the wood to make charcoal, and I'll use that to make torches so I can mine to find, you know, some better materials. It's building up, basically. And so this is a nice example of that, right? This one command awk lets us do a lot of manipulation. This one command and just this one way of using awk, just specifying a separator and printing a field. So be thinking about that as you're doing PA4, and you know, imagine wildly, right? I want this to do this amazing thing that's going to look like this and have all these features and capabilities. Go wild with your imagination for what you want your program to do, and then start trying to figure out how to do it. And if you don't know a way to do it, think about how to break it into smaller pieces, sub-problems, and try to figure out how to do those and then put those together, right? And that's to me the essence of programming. And the better you are at doing that, the more successful you are at tackling whatever random problem someone throws at you. All right, so someone asked, how do you make this remember things from run to run? That's where we can use an output file. So I could do something like, you know, I could echo all of this, and I could put this into, you know, log file. And now if I do S1, and I'm Nick, and I'm born today, and I do this, and I'm Sally, and I'm born at the end of the month, and I do this, and I'm Zog, and I'm born, you know, somewhere in the future. Well, if I look at my log file, I've got a record of all those different runs that I made now, right? Because all I'm doing is I'm using an echo statement, but I'm saying echo this line of information, but instead of displaying it to standard out, send it to an output file, and the two greater than signs say append it to the bottom of an output file. And so, you know, I've got a history, and I can log out and log back in, and this will still be here because it's just a file on my hard drive. So that's probably the main way to save things from run to run, is to start using files like that.
And so if we write this and put that in the script, when you are running the program, will it just create its own log file on your system?
Yes. So remember, if you're on the Linux server, which is where this is all supposed to live, there's a subdirectory called calendars, and you can create your own directory under there for your group and use that as a place to put your files. And then, you know, anybody who runs your script, as long as your script says, hey, you know, let's read file from /temp/calendar/ you know, super amazing group 12 /log file, right? It'll be the same file. And as long as that file is set to be readable by everyone. Now that's not super secure, right? Someone can come along and clobber your file, but if we're playing nicely, right, which we are in this class, so you can use that as a shared file area. And we have one temp file in there already, which is cool. All right, so that's one purpose of all of this, is just to kind of you know, push this idea of thinking in terms of building blocks, right, and breaking things down. But this also shows you how to call you know, scripts from inside a script, how to pass information to scripts, how to get information back from a script, and in particular this idea of breaking up a date, which will be a useful thing. But dates are also interesting because, you know, for example, you might want to know if someone's trying to schedule an appointment in the past. And you might say, you know, if today is November 5th, you're not allowed to schedule an appointment for November 1st or for September 30th. Unless it's September 30th, 2025, right, which is in the future. So you need to do some comparisons on dates. Or you may want to, you know, have a feature that says, you know, show me everything coming up in the next 7 days. And you'd want to go through your list of appointments, and for each date know if this appointment is you know, 7 days or fewer in the future. And so one useful command for doing things with dates is the date command. So date by itself shows you the current date. It's the day of the week, it's the month day, it's the timestamp, it's our time zone, and it's the year. But it's worth spending some time looking at the manual page for date, because it has about a gazillion options. And one of the options is I can say date --date equals, and I can give it a string, and it will display the date corresponding to that string. You can allow time travel. I'm okay with that. You could have a separate checkbox for, like, you know, are you a time traveler? And then you could have dates in the past. That would be fun. So I can say date --.
Paradox, right? If you set the appointment in the future and then move to the past, then technically the appointment hasn't been set yet.
Well, that's true. You could put a little end user license agreement saying the person agrees not to create paradoxes. There you go. So let's say --date equals, and let's go September 4th, 2021, which might have been when we started. I don't think it was. And now the date command displays, you know, the same date information, but for this date. Well, maybe that's useful, maybe it's not. I don't know. Here's one thing we could do with this. If I took this and I piped it into awk print $1, separated by spaces, I can see what day of the week September 4th was. And if I wanted to look at September 7th, that tells me it's a Tuesday. And I could, say day of week equals backquote all of this stuff. And now day of week is equal to Tuesday. And if I had, 2022, I could see that that's going to be on a Wednesday. So I could use this inside a script if I wanted to do something special with days of the week, right? I don't have to do all the weird math that one normally does with days, months, and years to figure out what day of the week something is. I could simply take my date, pass it to the date command with this -- date, print out the first field, capture it in backquotes, that tells me the day of the week.
You have date equals and then a specific date. Could you put like a $, whatever for what the user chooses?
Yep. So I could say read DD, and I could say, September 7th, 2022, and then I could say date equals $DD, and it'll show me the day of the week from that. So date is a real workhorse, and like I say, it's worth going through here and looking at this. But a nice thing about date is you can display the date in different formats, right? I can say date plus % Y, and it'll show me my 2-digit year if I want to introduce a Y2K thing. I can say plus, I'm doing this from memory here, %M, %Y, and maybe I can do %D, %M, %Y, and so now I've got, 5th November 2021. But take a look through here, look at your different options. All of these are different ways that you can display the date. I can just display the century, right? But one that's really, really useful is %S, lowercase. It's the number of seconds since the epoch, January 1st, 1970. So if I say date plus %S, that tells me how many seconds have passed since January 1st, 1970, midnight. And if I do this again, it's 8 seconds later. And we can do a few things with this. One of the things we can do is we can compare two dates and see which one comes before the other. This will give me the number of seconds since, time 0, and if I compare that to a different date, like, date -- date equals November 6th, 2021, that's the number of seconds corresponding to midnight, November 6th, 2021. Well, this number is bigger than this number, so this date is in the future. How much bigger is it? I can just take the difference of these. I don't know if this is too big, right? So that's the number of seconds until we get to midnight, January 6th, 2021. So we can compare dates, which is useful if you're trying to, find appointments in the future or delete appointments in the past or things like that. We can also see how far apart two points in time are by just, printing each of those dates with a %S and then subtracting them. That'll give us the number of seconds. If I divide that by...
compare like the chosen date to just the date function, that wouldn't work there because there's all the Saturdays and all the other stuff in the date then.
Right, but if you just do date with a %S, then you get this nice number of seconds. But yeah, if you just do date like this, then you've got to know, right? So September comes before November, but September 2022 comes after November 2021, and that kind of thing. Plus, if you're trying to convert to like an actual number of days from one to another, you got to deal with leap years and all of that good stuff.
Yeah. Okay.
So play around with date. All right. Send me an attendance note on the way out. Have a great afternoon. If I don't see you in 2:15, have a fantastic weekend. Otherwise, I'll see you in a half hour, and then you can have a fantastic weekend. All right. Thanks. Catch you next time.
Thanks.